The vast, cold darkness between the stars is not empty. It is an ocean, and occasionally its currents send messengers washing up on our distant shore. For the third time in recorded history, one of these messengers has arrived. But this visitor isn't just a piece of debris. It is an anomaly, a scientific puzzle box traveling at impossible speeds. And it is already rewriting what we thought we knew about the galaxy. Now let's access the field logs and analyze the true nature of this incredible visitor. It is called 3I/Atlas. The 3I designates it as only the third interstellar object ever confirmed. It was discovered in July of 2025 by the Atlas survey in Hawaii. And in the 4 short months since its discovery, it has electrified the astronomical community. It has generated a frenzy of observation, resulting in nearly 100 scientific papers. A new record. This isn't just another comet. This is a data-rich messenger from a completely different solar system, and it arrived just in time for its most dramatic moment. The moment of judgment. This is what astronomers call perihelion, its closest approach to our sun. On October 29, 2025, 3I/Atlas plunged inwards, reaching a distance of 1.4 astronomical units from the sun. That is 1.4 times the distance from the Earth to the sun, placing it well inside the orbit of Mars. This is the moment the comet truly comes alive. Bathed in the intense, unfiltered glare of our star, its surface begins to boil. Ices that have been frozen solid for billions of years are violently transforming directly into gas. This is sublimation. It's the process that creates a comet's signature glowing atmosphere, the coma. It's the engine that blasts dust and gas millions of kilometers into space to form its tail. At perihelion, 3I/Atlas is at its absolute peak activity, a blaze of transformation revealing its deepest, most primordial secrets. We should be seeing everything. We should be measuring the exact composition of its ancient ices. We should be watching its tail evolve in real time. But we are seeing absolutely nothing. Silence. Because from our vantage point on Earth, the comet has vanished. It has flown almost directly behind the sun. This is a solar conjunction, and it is the worst possible timing. We are blind. Our most powerful telescopes, from Earth and in orbit, are completely dazzled by the sun's glare. The comet is right there, at its most active, and we are forced to wait. We must wait until early December, when its orbit finally carries it out of the sun's blinding corona. Only then will we see what the encounter has done to it. The entire scientific community is holding its breath, waiting to see what emerges from the fire. Will it be a spectacular, active comet, or will it be something else entirely? But while we wait for that new post-perihelion data, we must analyze the data we do have. And that data already tells an impossible story. It begins with its discovery. This wasn't an easy catch. The object was first spotted in July 2025 by the Asteroid Terrestrial Impact Last Alert System, or ATLAS. It was exceptionally faint, just another moving speck against a background of static stars. At first, it was logged as just another comet, perhaps a long-period visitor from the deep freeze of our own Oort cloud, a routine observation. But when astronomers around the world began to plot its orbit, the entire picture changed. The calculations simply did not add up. Comets from our solar system, even the most distant ones, travel in vast closed loops. They are bound by the sun's gravity. They fall in, swing around the sun, and eventually travel back out. But they are always pulled back. This one is not coming back. Its trajectory is what we call a hyperbolic orbit. It is a perfect, open-ended curve, a clear mathematical signature that it is not gravitationally bound to our sun. It is an intruder, a true outsider passing through, its path forged by the gravity of another star, countless light years away. This stunning confirmation came from one single, shocking piece of data: its velocity. The objects in our solar system follow a strict speed limit, one that is governed by the sun's immense gravitational well. The fastest-moving planet, Mercury, orbits the sun at a blistering 48 kilometers per second. That's over 107,000 miles per hour. Objects falling in from the Oort cloud, accelerated by the sun's pull for millions of years, might reach similar speeds as they graze the sun. But 3I/Atlas isn't just matching that speed, it is shattering the limit. When we first clocked its approach, 3I/Atlas was traveling at an incredible 58 kilometers per second. 58 kilometers per second. That is 10 kilometers per second faster than the fastest planet in our solar system. It's moving so fast that the sun's gravity is like a gentle breeze trying to stop a freight train. It can tug on it, it can bend its path, but it cannot hope to capture it. This velocity is the comet's interstellar passport. It is definitive proof. It proves that 3I/Atlas was born elsewhere, in a stellar nursery we have never seen. It has likely been traveling for billions of years, a lonely nomad in the galactic dark. And this incredible, impossible speed is what makes its arrival so much more than just a discovery. It makes it a profound puzzle, because its speed isn't the only thing that makes it an outsider. There is something else. Something that makes its arrival not just rare, but statistically bewildering. We are about to see that its speed is just the first anomaly in a chain of impossibilities. The story of its discovery is quickly being eclipsed by the story of its path. When we compare it to the only other interstellar visitors we've ever met, 3I/Atlas doesn't just stand out. It breaks the mold. It's not just an outsider, it's the ultimate interstellar weirdo. And its weirdness is about to challenge everything we thought we knew about how these objects travel. To understand just how strange 3I/Atlas is, we must compare it to our only other known interstellar visitors. Our entire dataset consists of just two previous objects. First, there was 1I/Oumuamua in 2017. It was a bizarre, tumbling, cigar-shaped object, small and rocky, which famously accelerated away from the sun without any visible coma. It was a profound mystery, and it remains one to this day. Then came 2I/Borisov in 2019. This one, at least, looked familiar. It was clearly a comet, with a visible coma and tail, behaving much like the comets from our own Oort cloud. It was the normal one, the one that told us other solar systems probably make comets just like ours. That assumption is now in question. These two objects set our expectations. We expected interstellar visitors to be either small, rocky anomalies like Oumuamua, or familiar icy comets like Borisov. 3I/Atlas is neither. It shatters the scale. Oumuamua was estimated to be at most a few hundred meters long. 2I/Borisov was larger, perhaps just under a kilometer wide. 3I/Atlas is a monster. Current estimates place its nucleus at a staggering 5.6 kilometers wide. It is a mountain, an order of magnitude larger than its predecessors. And its speed, as we've established, is in another league entirely. At 58 kilometers per second, it is moving at nearly double the interstellar cruise speed of the other two. It is bigger, it is faster, and it is fundamentally different. But even those shocking statistics, its immense size and blistering speed, are not the real anomaly. Not by a long shot. The true weirdness of 3I/Atlas is its path. Its trajectory is impossible. To understand why, you have to visualize our solar system. Think of it as a flat disk, a gigantic celestial racetrack. All the planets, from Mercury to Neptune, orbit the Sun on this same flat plane. This is the ecliptic. It's the plane of our solar system. When Oumuamua arrived, it plunged in from above at a steep 60-degree angle to this plane. When 2I/Borisov arrived, it dove in from below at a 44-degree angle. This is exactly what we would expect from random interstellar travelers. Space is three-dimensional. The odds of an object flung from another star just happening to arrive on the exact same flat plane as our solar system are astronomically low. So low as to be functionally zero. It's like throwing a pebble from a mile away and having it land perfectly flat on a single vinyl record lying on the ground. And yet, that is exactly what 3I/Atlas has done. This comet is not arriving from above or below. It is approaching us almost perfectly within the ecliptic plane. Its orbital inclination is a mere 3 degrees. It is flying flat and level, perfectly aligned with our own planets. This is the T-bone anomaly. An object from another star, traveling at double the speed, has merged into our solar system's lane almost perfectly. The statistical coincidence is mind-boggling. It is so improbable that it forces us to ask new, uncomfortable questions. Is this a coincidence? Or does its origin, deep in the galactic core, somehow favor this plane? Or is this alignment telling us something else entirely? This trajectory, this impossible path, is what makes 3I/Atlas the ultimate interstellar weirdo. It has arrived as no other object ever has. And as we are about to see, its impossible path is matched only by its impossible chemistry. The real mystery is just beginning. What it's made of is even stranger than where it's going. Its path is an anomaly, but its physical nature is an outright contradiction. This is where the data becomes truly bizarre, where 3I/Atlas earns its title as the ultimate weirdo. First, we must consider its age and origin. It appears to have originated from the thick disk of our galaxy, a region far older and more chaotic than our own quiet neighborhood. An ancient traveler. Its estimated age is a staggering 7.6 billion years. That makes it far older than our entire solar system. It is a primordial relic, a piece of a stellar nursery that formed and died long before our sun even ignited. And this ancient object is behaving in ways we have never seen. This is Anomaly 1, the brightness. As it approached, the TESS satellite, our transiting exoplanet survey satellite, was staring right at it. TESS is designed to detect the tiniest dips in starlight, so its measurements are hyper-precise. As 3I/Atlas got closer to the sun, it of course got brighter. But it didn't just get brighter, its flux, the amount of light we received, increased 5 times more than all our models predicted. It was flaring, becoming far more active, far earlier than any known comet should. This led directly to the next mystery. Anomaly 2, the light. When we analyze the light reflecting off a comet's coma, we look at its polarization. It tells us about the structure of the dust particles. Comets from our solar system have a well-defined, predictable polarization signature. 3I/Atlas does not. It is exhibiting the most extreme negative light polarization ever detected in any comet ever. The data is so far off the charts that some astronomers have had to recheck their instruments. It implies the dust in its coma is unlike any dust we have ever sampled. A completely alien structure. But the dust is nothing compared to the gas. This is Anomaly 3, the alien chemistry. comets are dirty snowballs. Their activity is driven by the sun heating their ice. In our solar system, that ice is overwhelmingly one thing: water. A typical comet is a water ice bomb. When it gets close enough to the sun, the water ice sublimates, and that is what drives its activity. 3I/Atlas began sublimating when it was still 5 astronomical units from the sun, out near Jupiter's orbit. It was far too cold for water ice to be the main engine. So what was boiling off? Spectroscopy gave us the answer: carbon dioxide, CO2. This comet is not a dirty snowball. It is a dirty block of dry ice. Its atmosphere was found to be dominated by CO2 at a shocking 8-to-1 ratio over water. This is the complete and total opposite of comets from our solar system. It tells us it formed in a place that was either incomprehensibly cold or had a vastly different chemical makeup than our own. But the chemical mystery only gets deeper. Anomaly 4. The sudden shift. As it continued to race inwards, the comet's chemical signature suddenly and dramatically changed. First, astronomers detected a massive, unexpected surge in water vapor, as if a totally different part of the comet had suddenly been exposed to the sun. A new layer. But then came the metals. At first, its spectrum showed traces of nickel, but just recently it began spewing large quantities of iron. This is highly unusual, but the sequence is the mystery. Nickel without iron, and then suddenly iron? It suggests a body that is not well mixed, a lumpy, heterogeneous block of different materials. And all of this culminates in the most visible, baffling mystery of all. Anomaly 5. The anti-solar tail. This is the one that defies basic physics. A comet has 2 tails,
the immense
a dust
gravity
tail
and radiation
pushed
of the
by
star strip
sunlight
material from
and
the
an
comet's
ion
nucleus,
tail,
forming
pushed by
shimmer-
the solar wind. Both of them, always, without exception, point away from the sun. It's the fundamental rule of comets. When 3I/Atlas was first observed in detail, astronomers were baffled. It appeared to have a tail, but the tail was pointing towards the sun. This is, simply put, impossible. It has been called the anti-tail, and it's not a true tail, but rather a trick of perspective. It suggests we are seeing a flat sheet of debris, and because of our perfect alignment on the ecliptic plane, we are seeing this debris fanned out in front of the comet along its orbit. It is a direct consequence of its impossible T-bone trajectory. 5 anomalies: impossible brightness, impossible polarization, impossible chemistry, impossible composition, and an impossible tail. Each one of these would be the discovery of a lifetime. To find all 5 in one object is a scientific revolution. This is not a comet. This is a puzzle. And our best chance at solving it is happening right now, far from Earth. We are not the only observers, while Earth's astronomical community waits for December. 3I/Atlas has already had its first close-up. It skimmed the red planet at a distance of just 0.19 astronomical units, a cosmic near miss. And we were waiting for it. We have robots on Mars. On the crimson, dusty surface, NASA's Perseverance rover was given new commands. Its sophisticated Mastcam-Z and SuperCam instruments were angled away from the Martian landscape and up towards the faint nighttime sky. It is the first time in history an object from another solar system has been photographed from the surface of another world. At the same time, orbiting high above the rover, the European Space Agency's ExoMars Trace Gas Orbiter swiveled its instruments. It pointed not down at Mars, but out into the black, analyzing the comet's chemical signature from a unique Martian vantage point. This data from Mars is a priceless time capsule, capturing the comet's state just before its violent encounter with the sun. That data is now in transit. Now we wait for the comet to emerge from the fire.
Our
Earth
turn.
gets its turn.
Hopeful.
On December 19th, 2025, 3I/Atlas will make its closest approach to our own planet.
The diagram
pass us
illustrates
at a
that while the
safe,
Earth-Sun
but
distance
wonderfully
defines
close,
one astronomical
one
unit, or
unit.
AU,
This is the moment the global campaign begins. As it clears the sun's glare, every major telescope on Earth and in orbit will lock onto it. We will finally see what perihelion has done. Has the sun's heat triggered new, even stranger chemical reactions? Has it fractured the nucleus? Has its impossible brightness flared even higher? This is our last, best chance to study it from home. A final, intense observation window before it races away forever. But it is not the final goodbye. It has one last appointment. The comet's hyperbolic trajectory is now taking it rapidly back towards the outer solar system. On March 16th, 2026, its path will carry it just 0.36 astronomical units from the king of our solar system, Jupiter. And we have a sentinel waiting there too. The Juno spacecraft, currently in orbit around the gas giant, will be retasked for one final historic encounter. Juno will give us our farewell snapshot. It will be the last pair of eyes to ever see 3I/Atlas. Open bracket BREATH close bracket. And then it is gone. It will plunge back into the interstellar ocean, carrying the heat of our sun and the secrets of its origin with it. A 5.6-kilometer wide, 7.6 billion-year-old riddle defined by 5 impossible anomalies that aligned with our solar system like a key in a lock. This ultimate interstellar weirdo has given us a profound gift. It has, in its brief, chaotic passage, forced us to rewrite our assumptions about the galaxy. Its bizarre chemistry and impossible trajectory are a powerful message from another star system. The message is simple. The galaxy is infinitely more diverse, more strange, and more complex than we ever dared to imagine. And we are only just beginning to read the messages washing up on our shore.